Good afternoon, everyone. A warm welcome to all of you. Thank you for joining us today for the Lancaster University AI Masterclass. We are delighted to see such enthusiastic participation from students who are keen to explore the exciting world of artificial intelligence, computer science, and data science. My name is Rajni Saini, and I'm a Regional Manager Strategic Alliance team at StudyIn. I will be moderating today's session. At StudyIn, we work closely with leading global universities like Lancaster University to help students gain clarity on international education opportunities and make informed academic and career decisions. Today's masterclass is specially designed for prospective postgraduate students and focusing on how AI and related disciplines are transforming industries, research, and everyday life. The session is closely aligned with Lancaster University postgraduate program in AI, computer science, and data science, and aim to give you a clear understanding of academic structure, industry relevance, and future career path in this rapidly evolving field. We are extremely honored to have an accomplished academic and expert join us today as our speaker. It is my pleasure to introduce Dr. Bryan M. Williams, Senior Lecturer in Computer Vision, School of Computing and Communication, Lancaster University. Dr. Williams brings intensive expertise in AI and computer vision, and today he will be sharing valuable insight into the field as well as what students can expect when pursuing advanced studies at Lancaster University. Before we start the session, we would like to inform everyone that the QA option is available at the bottom. Kindly type your questions in the box during the masterclass, and we will address them one by one after the session. Also would like to request everyone to be there at the session till the end so that we can take your attendance and provide you the certificate accordingly. Without further delay, I would like to hand over the session to Dr. Williams. Dr. Williams, over to you. I'll just stop my screen and you can share your screen.
Thank you, Rajni. Let's see if AI will let me share my screen now.
Yeah.
So if you could just confirm for me, please, that you can see the screen.
It's visible now. Yeah, I can see.
Brilliant. Brilliant. Thank you very much. Thank you for the introduction. So good morning from the United Kingdom and good afternoon to everybody in the audience. I am Dr. Bryan Williams. I'm a senior lecturer at Lancaster University. So what I'm going to take you through today is some of the work that we do at Lancaster in artificial intelligence, some of the recent developments in artificial intelligence that I think make it a really exciting area to work in these days, and what doing a master's degree and having a master's degree really means these days. So I'm Bryan Williams. I am a senior lecturer in computer vision. I'm also Director of Equality and Diversity and Inclusion at Lancaster. I'm Director of the ICVL and H-Unique research groups. So I'm one of these academics. As with many academics in the UK and all over the world, we have multiple roles within a university. Part of our job is to help the university stay running and stay efficient and continue to be a good place for academics and researchers and students to work at. So that's my equality, diversity, and inclusion role. And I also am very heavily involved in research. So the majority of my work is in research. And I believe that any academic who is especially heavily involved in research should also be involved in teaching. Because part of our responsibility is to advance what we know, to advance science and the frontiers of knowledge that we know already, and then to pass that information down to the next generation, which is you. So you will be the next generation of AI researchers and AI people working in industry. So my research, as Rajni pointed out earlier, is focused on computer vision. So I work primarily in the development of core methodology. My background is that I'm a mathematician. I'm not actually a computer scientist. It's always quite funny. I have to tell my students every year that they've attended far more computer science classes than I ever have. So they know far more about computer science than I do. But the underpinnings, I feel, in artificial intelligence cross so many domains. So they cross mathematics, they cross computer science, psychology, sociology. So my research falls into computer vision, which is a branch of artificial intelligence that deals with the interpretation, the analysis, the understanding, and the associated decision-making with signals and with images and video content. So my core areas of work that motivate the problems that I focus on come from medical imaging and forensic identification. So the reason that I'm so interested in those particular areas is that accuracy is a really important thing. So being certain of what your model's achieving and being able to convey that certainty is really critical in these particular areas. And that's especially important today as the AI that we've been developing over the past 20 years is finally reaching the point where we can actually deploy it, which has always been our goal. And we're actually reaching the area now. So we've been working in AI really since the 60s. So we're in 2026 now. So we've had a good 85 years of developing artificial intelligence. And we've gone in that time from having the kind of rudimentary but fundamental rule-based approaches that we used to have that were essential, that were the beginnings of artificial intelligence, through to developing variational modeling in the 90s and graph-based modeling in the 2000s to the deep learning kind of resurgence, because deep learning was something that we always studied in the past, but it was never really feasible to implement this in the real world until around about 2010, 2012. So we had in 2012 what was considered the deep learning breakthrough, when all of our attention suddenly shifted to machine learning models, and much more heavily to machine learning models. And then more recently, we've had shifts towards transformers, towards foundation models, and of course, the current interest in generative AI. So there's a lot of concern at the moment that with these kind of shifts, with any kind of industrial revolution, there's a risk of losing jobs. And unfortunately, that is true. So it happens in the Industrial Revolution in the 1900s, people lost jobs to machinery, but then they found jobs elsewhere. And I believe the same will happen with artificial intelligence. In fact, the current prediction is that as many jobs will be lost, more jobs will actually be created. Created. And those jobs that will be created will be in artificial intelligence, and they will demand some sort of knowledge, some underlying understanding of artificial intelligence that goes beyond. And in fact, the prediction is that AI is expected to contribute more than $15 trillion to the economy by 2030. So there's a lot of hype going on about artificial intelligence at the moment, and that has pros and cons. Some of it is good, some of it is bad. My feeling has always been that maybe too restrictive, that we shouldn't necessarily release artificial intelligence on the world until we understand every limitation. But that's just not practical, and it's not what's happened. So what we need in the future, as the world is changing, as the job market is changing, is we need people who really have a deep understanding of artificial intelligence. And that, in my view, in my experience, is not what we have now. And that's why I think the study of AI is so important. So AI is something, this is why it's a really exciting time to work in AI, because it's something that we're really seeing actually in practice and not just in research labs, which is pretty much where it's been for the past 20, 30 years. We've developed it in the labs, and we've always had the intention, the desire to take this out into the real world and have it ready for use. And we're reaching the point that AI is being released now. So we have things like automated disease detection. So one of my core areas of research is in disease detection and the automated analysis of medical images, so that we can achieve things like in the example that I'm showing here, we're trying to diagnose the different stages of diabetic retinopathy, which is an eye disease. So what we're looking at here is a color photograph. And on the left-hand side, you can see that inside the eye, there's some blood flow. There's excessive blood flow, which is indicative of a hemorrhage, which is, of course, not a good thing. And it's one of the leading causes of irreversible blindness, certainly in the UK, but all over the world as well. And because it's so prevalent, the diagnosis of this disease is really, really, really important. And the automated diagnosis helps with the timely detection, which is so important. So we're at the point now that we can actually diagnose diabetic retinopathy and even distinguish the different stages of retinopathy and other eye diseases such as glaucoma to a really, really strong accuracy. Or if we're so inclined, another problem that we like to tackle is image classification. So in this case, for example, we've been able to distinguish an image of a wolf from an image of a dog. We can also distinguish images of cats. So we can determine different types of animal. We can determine different types of flower. And we can do this entirely automatically by just inserting an image into our model and determining the resulting classification. And of course, everybody's familiar with ChatGPT these days and generative AI chatbots, which provide really, really surprising levels of authenticity. So one of the traditional complexities and the things that's really difficult to achieve with generative AI is realism. So in medical imaging and forensics, in classification, the key measure of success is how accurate we are. But in generative AI, there's no ground truth. So we don't measure it in terms of accuracy. What we measure it in terms of instead is realism. So we're at the stage now we can generate realistic images, which we know has pros and cons, and we can generate realistic text. And we can develop chatbots. One of the interesting things once ChatGPT was released, I think, was just how quickly we all of a sudden had so many different chatbots become available with companies. And we've also and that was really exciting at the time, but we're really starting to see now that many of those chatbots are not very good, in fact, and lack the fundamental understanding that people expect. And I think that's one tricky thing with this rapid deployment of AI is that people misunderstand what AI can achieve at the moment, and they expect potentially too much from it. So at the moment, everything that we have in AI, and this is not everything, this is a very small snapshot, but what we have in AI is incredibly impressive, and it seems incredibly impressive until that moment, of course, when it fails. And this is the difficulty, is that I think people don't quite understand that the level of success that AI actually has. So AI is incredibly impressive. It can achieve a lot of things, but is it perfect? No. There's a huge amount of hype that really we have to be hesitant about. So in medical imaging, for example, if we take somebody who has a particular disease, a very serious disease such as glaucoma, retinopathy, cancer, and we accidentally diagnose that as healthy, that is a critical problem. And we have to be aware of that, and we have to deploy AI in a responsible way. So probably the most common example that I always think that everybody knows is in the distinction of wolves and dogs, which is a relatively trivial problem to most people. No one's going to die well, hopefully no one's going to die if we accidentally classify a dog as a wolf. But this particular problem actually gave rise to something quite interesting. So there was an exercise a couple of years ago where people were trying to develop a classifier for wolves versus dogs. But many of the dogs were being incorrectly classified as wolves. And the question was, why is that happening? And that's one of the difficulties with kind of black box approaches, which deep learning is generally considered to be, is that you can't easily say why it has gone wrong. So in this case, there was a particular pattern that was spotted in the misclassification in all of the images that were wrongly classified as wolves. And the pattern was that in all of the images of genuine wolves, there's snow in the background. In most of the images where a dog was classified as a wolf, there was snow in the background. And that was determined by the development of methods like the GradCam, which allows us to determine which area of the image is actually contributing most to the classification. So that led to the development of approaches like GradCam, of class activation maps, which led to the development of attention, which led to transformers. Okay, so that's a really nice example of the mix of academic research with genuine real-world application. And of course, everyone knows the issue with ChatGPT's question, how many R's are there in the word strawberry? It usually gets that question wrong. Although I did try yesterday, and apparently that's been corrected. It got it right, and I was quite surprised. So where are we right now with artificial intelligence? So the stage that we're at is we're still in the lab, or at least I'm still in the lab. But we've moved to the point where artificial intelligence is really being able to be deployed in the world. So we've got it in non-critical environments like virtual assistants. We've got it in self-driving cars. Now, self-driving cars, I think we can all agree, is a critical scenario, but we've got it in with additional safety measures. So we're not trusting AI purely by itself yet, and nor should we be. We've got it emerging in medicine, except that we don't think of it as diagnosis, we think of it as disease detection, which is a very different thing. And it's an idea that I actually like because my personal belief is that we should develop AI to be as fantastic as it can be, not necessarily as complex, but to achieve as much as possible, but that should be working alongside humans and not instead of humans. And every discussion that I've had with patient groups has concluded really the same thing, that they do not want AI to replace things like doctors. They still want to be able to see them. So in healthcare and medicine, where we've seen a huge amount of work and development in artificial intelligence for the past 20 years, my work focuses on three different types of problem. So you've got fundamental image processing and analysis, you've got diagnostics or disease detection, and device development. So in image processing and analysis, what we focus on really is supporting the technicians, radiologists, and reading centers in being able to find pathologies in images that can be otherwise difficult to see and easily missed. So they make the analysis for a human take up far too much time and also make them less accurate. So a lot of our work here focuses on things like enhancement, localization, extraction, the automatic tracking and measurement of tumors. And it's focusing on measurements of things that people themselves find it very difficult to do, that we can't actually process in our brains. And that is one of the ways in which we develop AI to not just be as good as a human, but better than a human. In terms of disease detection, we're focusing now not just on the detection of individual diseases, or even severity, but the study of comorbidities and the detection of diseases when other diseases may also be present. So we're moving away from this kind of lab-based scenario where we say, oh, we only have in this data set, we have glaucoma and we have not glaucoma. Can we distinguish them? To saying, okay, we've got this huge data set that can contain many diseases, which is far more complicated and requires far more sophisticated model development. And a really cool thing that we're doing at the moment is in terms of device development. So most of the time when we're working with artificial intelligence, in most domains actually, the method of acquiring the data is fixed. So we have maybe cameras or we have CAT scan machines or MRI that can deliver the data to us and then we start to work with it. But what we actually started doing maybe 10 years ago is started to develop devices that are AI enabled so that we can achieve more at the point where you're with the person or you're with the patient because of artificial intelligence. So nowadays we have cameras that can track relevant points in the eye so you can get a much better quality image. One of the projects that I'm developing actually with a clinic in Pondicherry, near Chennai in India, is about trying to achieve low cost eye imaging of the inside of the eye. So you can achieve the same performance with, I think, a £500 camera that you otherwise would need in say, the UK. We have cameras that cost £200,000, which is ridiculous. But we can achieve the same performance now by developing something that's AI enabled and costs maybe £500. So one particular project that I'm focused on with a clinic in India, so this is the Aravind Eye Care Clinic in Pondicherry near Chennai, is for the diagnosis of glaucoma. So this is the one that I'm mentioning, where we're working on the development of analysis from a £500 camera versus a £200,000 one. So the idea here is that we want to be able to diagnose glaucoma, especially when comorbidities are present, when other diseases are present. And our approach to doing that is to develop a way to detect the optic disc. So here we can see two images from two different patients. We've got one healthy at the top and one with glaucoma at the bottom. And there's quite a lot of differences between those two images, but it's very difficult to say actually what indicates glaucoma and what doesn't. And it's a very difficult disease to diagnose. What we focus on is this bright region in the center of the bottom image and in the center, but just to the left of the top image. So this is called the optic disc. Now, humans, when we look at that, what do is we look at the vertical difference between the very bright region and the less bright region, and we calculate the quotient of that. And that gives the kind of indicator of whether or not somebody has glaucoma. And that is something that we can do. It still takes time, but we can do it as humans. We can do it relatively quickly. And we get maybe 70, depending on the population, between 70 and 85% accuracy with that. So that sounds quite good, but in terms of medical diagnosis, that's terrible. So what you need, in fact, is a whole host of other devices and of other tests to be run, which of course takes a huge amount of time for the patient and costs the clinic a huge amount of money to buy those devices. What we do instead is we develop a way to detect the overall boundaries of these particular objects. So we can actually detect where the boundaries of these objects are, and we can draw them. And we can calculate the quotient going all the way around the object, which we know is important, but as humans, we don't have the time to get out the calculator and start calculating the quotients all the way around. Anyway, and what a computer can do much better than a human is interpret this kind of shape. So to a human, all we can see is that the bottom one is a little bit bigger. Is that important? Not really, to be honest, in terms of diagnosis. That's not going to help us that much. What really matters is the shape itself and the profile of the shape. So as humans, we can't really detect any difference in the profile. But a computer can very easily, it's a very trivial problem for a computer to plot, to refactor this in terms of polar coordinates, and then replot the curve. And now we can see a very significant difference, that the healthy case has two peaks, the glaucoma case has one, and we achieve this entirely automatically through the development of these techniques. And if we can reformat the data in this way, we can then further develop statistical tests to analyze this kind of profile. And in doing that, we achieve an accuracy of 93%, which is a huge jump from this 70 to 85% accuracy. Okay. So this is one area where we can actually develop artificial intelligence for a good thing. We can develop it in a way that we can present to the patient, this is what's going on, this is why you're being diagnosed in this way, and we can be even more accurate than the human. Okay. So another area of my work is in forensic identification. So this is another area where accuracy is really critical. So probably we're all familiar with things like we're all familiar with things like fingerprint comparison, and even more recently, there's a lot of interest in analysis of palm creases, so the skin creases that you see on your palm. And a very recent payment system is based on analyzing the blood vessel patterns in your palm that are largely expected, not necessarily known, but expected to be sufficiently unique. Now, in most cases in biometrics, which is the study of identifying people based on trait and distinguishable traits, in most cases of that, the data is captured in a very clinical lab-based way. So for the looking at things like the veins in the palms, we use infrared technology to do that because that helps us to see them. For fingerprints, we use a fixed area in a pad of paper and we use ink in a standard approach. And that's interesting in itself. It's very interesting study to ensure that that is actually accurate and to analyze just how useful that is. My personal interest is in scenarios where we don't have these kind of clinical conditions, where we're out in the real world. And that's interesting to me for two reasons. So on the one hand, you have a much more difficult and much more complex problem because you can't necessarily say, okay, we're going to definitely be able to find this area of the vein pattern at this particular point. We're going to have this amazing technology that can show us a fantastic view of the vein patterns. Instead, what I have is incidental data. So that is a much more difficult problem to solve. And it's also, for me, much more important in terms of an application also. So our key goal with this particular project, this is the H-Unique project that we're running here at Lancaster, is to be able to identify people based on incidental images of the person's hand. We do that because the evidence that we have from bodies like the National Crime Agency, Interpol, and the FBI do not show any other kind of identifying traits. So the evidence is usually in video format, sometimes in image format, and it doesn't show anything that would be typically considered to be an identifiable trait of a perpetrator. And the particular focus for this is in cases of child abuse, where the abuser actually captures the data themselves, the images themselves, and of course takes care not to show their face. So the evidence that we have is entirely incidental. So we have to work with this kind of incidental information to be able to extract the detail in a meaningful way. So we have to be able to extract meaningful information. We have to understand the limitations of the data in terms of what we can identify in terms of vein patterns and how useful those patterns, not necessarily vein patterns, but also skin creases, to identification, and we have to do it in a way that's going to be reasonably transparent, because there will come a point where we're having to present this evidence in the courtroom. So, in order to do this, when we first started discussing this 6 or 7 years ago, one of the things that made it so interesting was that, in fact, there was very little work in this area. And if we were ever going to be able to tackle this problem, we had to basically develop the whole thing from scratch. So there was work, of course, in blood vessel segmentation. That's one of the most popular tasks in computer vision. But there wasn't really any work in mapping out the blood vessels, which is what I am now interested in, is determining the center line of blood vessels and being able to draw a map of blood vessels that can then be compared. There's very little work in doing this incidentally, and there's no work in doing it from photographs of the hand. So in order to develop this project, what we had to do was develop our own concept of a problem. So we were the first people in the world to develop the automated centerline detection of blood vessels, so the automated mapping of blood vessels from photographs of the hand, and of course, even from infrared images of the hand. So it's very rare that we receive evidence captured in infrared, but it does happen sometimes. And of course, once we were able to extract the blood vessel patterns of the hand, we need a way to compare them. And this is another thing that's incredibly complex, because ordinarily when we're comparing something, we assume that there's going to be some easy basis for comparison, or some reasonable basis for comparison. So we might expect the same number of junction points, of nodes. We might expect that we're working within the same plane, or that we can orient the same plane. In this case, we have no real information at all. So we have to develop ways that can accommodate that. So we have to be able to determine where junction points are. We have to be able to relate them to different places in the image with techniques like positional encoding. And then we have to develop ways of comparing them when we don't even know necessarily just how many points are there to be compared. So we develop things like K-hop GCA in order to achieve that. So there's lots of challenges in real world problems. And one of the kind of strange things that I hear every so often, I get the feeling I'm hearing it more frequently now, but I'm not sure if I am. But I hear every so often is that surely this is an easy problem to solve. Surely all of the work in AI is done because now we have ChatGPT. And some of my students, they're very worried because my students, they're undergraduates in computer science, and they're hearing that, oh, maybe there will be no job for them in future. So they're really scared about that. And I tell them that's completely wrong. So they don't have anything to be worried about, in my view. So there will be some jobs that are replaced, but those jobs will be the kind of coding jobs. So jobs that you would trust AI to do, and jobs that, frankly, are a little bit boring. I think the jobs that will be retained are those that require understanding of artificial intelligence and that can start to tackle these huge number of challenges that do exist. So we've got challenges like data security and model security. So AI security, or secure AI, is a topic that's actually, it's been emerged only in the past couple of years. It didn't really exist as a subject before, but is essential for ensuring the security of our models, especially when an AI model is essentially an encoding of our personal data. Okay. So this is a really interesting topic at the moment. There's the question of model evaluation with annotated data and actually achieving those benchmark data sets, which again are still very small. And there's still, I think, an over-reliance on using annotated data sets. There's the question of transparency, which is a really, really hot topic at the moment. It's a really interesting one to study. So there's a question of how do we respond to this concept, this idea that AI is considered black box. So there's a lot of study in things like explainability, and uncertainty is a particularly interesting topic at the moment. And extending from, we're still going from moving from the lab into the real world. So developing models that can work reliably and reasonably with real world data. So to give an example, there was a model for, I think it was retinopathy detection, published fairly recently, and it was tested on a sample population from Singapore, which is a kind of historically Chinese population. And they got some pretty decent results, the authors of this paper. They got 96, I think, percent accuracy, which sounds fantastic. Then they tested the same model on a population from India, that was retrained on the population from India. So it wasn't just using this Chinese population. And they got all of a sudden 82% accuracy with the same model. And that is a massive shift that it would be for adoption entirely unacceptable. Okay. So what we're working towards at the moment really is the development of models that are accurate, that are transparent, that are explainable, that are reasonable to be adopted. And of course, we have this huge issue of the environmental concerns and the energy concerns that we have resulting from a lot of people training really, really large models. And in fact, I was quite surprised recently to learn that training models isn't even the core problem in terms of the impact on the environment. The problem is actually the deployment of really large models. So that is a kind of new area that needs to be addressed and needs to be tackled. So there's lots and lots and lots of interesting challenges that still remain. Right. So there's a lot of hype at the moment that says that AI is kind of here and we've achieved it and is amazing. And it is amazing where we've come, but there's still so many problems still to tackle. And if we can do that, then we can achieve so much bit by bit by bit, and it will be an incremental increase in terms of performance and in terms of capabilities. So from my point of view, what I'm excited to achieve over the next 5 years or so is to achieve stronger evidence for the courtroom, to achieve stronger supportable disease detection. And that can unleash things that humans at the moment can't do, like for me, the global tracking of offenders and actually the identification of suspects where we don't currently have any, and building things like transparent evidence for clinicians and to support legal proceedings. So what do we actually need to do in the future? So I think, and maybe this is just me, but I think the current topics that we need to focus on are things like explainability. It's building more accurate models. That's absolutely true. And that's been our focus in the past 20 years, and it's still important. But also now we need to focus on things like explainability and accountability and the interaction with the humans. And more these days, we're kind of coming out of the silos of working purely with kind of general data or purely with computer vision or purely with language. And we're developing hybrid approaches. So large multimodal modeling is a term that's emerged fairly recently. And we're moving on as well from this idea that we're solving AI problems only for themselves. So only for the scientific interest. So we're still doing that, absolutely, because that's how we develop the AI that can start to tackle these kind of global issues that we see today. So we can start to study and tackle ecology issues in the real world. But in order to do that, we have to do it responsibly. So there are some of the relatively new subjects that have emerged recently fall into the lines of things like sustainable AI and secure AI as well, and fair AI, so AI that can try to eliminate bias. And how does that look at Lancaster? So I said at the start, so I'm in the UK. I'm in a city called Lancaster. I'm just outside of a city called Lancaster. So we are based in the middle of the UK, almost. So we're pretty much halfway between London and Edinburgh. And we're just south of a region that on the slide, it looks a little bit like a puddle. In fact, what it is a collection of some really large lakes. So this is an area called the Lake District, which is a really beautiful place to visit. And we're very close to Manchester Airport. So if you want to come visit us anytime, your best bet is to fly into Manchester Airport and then you can take a train directly from the airport up to the city. And then we're just, I think, a very short bus ride away from the city. I think it takes something like 5 minutes. So we're very well connected internationally. And this is our campus. So you can just about actually see my office there. So where I am is if you see our crest where we've got, it says our campus, 560 acres, and you look just towards the top of that crest in the middle, you can pretty much see my office window. So I'm based in the south of the campus. So we look, that's a little misleading in a way. That looks like we're completely hidden in the countryside. Actually, if you look slightly to the right of this image, which is to the right is north, you can see the city of Lancaster just north of us. But it's a really beautiful self-contained campus. So I've worked in my career, I've worked in universities that are based in cities and universities that are based on self-contained campuses. And I always like the ones that are based on campuses more because we have a lot of facilities directly on the campus itself, while still being reasonably close to a city if that's where you want to go. So Lancaster itself, so it's a kind of medium-sized city in the UK. So our biggest cities are London and Manchester and Birmingham. So Lancaster's kind of in the middle. So we've got 140,000 people, and we're a very old city. So we have a huge number of fantastic old buildings. And in fact, if anybody's familiar with the conference, BMVA is the British Machine Vision Conference. It's kind of like the UK version of CVPR. We're hosting that in Lancaster in November this year. And we'll be hosting the dinner in our city castle, which is 1,000 years old, which is going to be really interesting. So even though we're kind of in the middle of the UK, we're a top-ranking global university. So we're in the world top 150, and we have been for a long time. We're always in the top 15 of the UK universities. And we're a very well-known one in terms of employers. So in terms of computer science, we're ranked 13th in the UK for computer science. And we have a huge focus on teaching, but also on research. So when I'm developing my teaching materials, which I have been recently, I've recently developed the new AI program for undergraduates in the department. What I'm very concerned with at the moment is ensuring that my materials, they're kind of research related, they're research led, so that what you're actually learning is relevant today in terms of research, but also in terms of industry. And they focus on the understanding of AI. And when you're trying to decide where you want to go for, especially for postgraduate study, which is a little bit more specialized than undergraduate study, there's a couple of things that I think you need to understand and you need to look into. So one of them is the course content. So you need to understand what is being taught, but another really is who is going to be teaching you. So are these people who are, say, focused only on teaching, who maybe don't do any current research, or are they current researchers? So at Lancaster, we're actually really lucky. We have some really great people here who do world-leading research. So one of the ways to tell what is world-leading research and what is not is where it's published and how many citations how many citations the work has or the individuals have. So they're not necessarily the best measures. Well, I think they are the best measures, but they're not necessarily the only measures. So at Lancaster, we've got people who publish in places like Nature, CVPR, at ECCV. So these are the world-leading conferences and journals. And what that means really, or what it indicates, is that the work we're doing has relevance. So it is current research. It's not just kind of doing some kind of simple application that anybody could do. Okay. And I think that that matters. So at Lancaster, you're going to be taught by people who are actually doing current research in these areas, but they're doing research that is publishable at the world-leading conferences like CVPR, which we manage to publish in every single year. In terms of what you're going to be learning, so we have two programs sort of related to artificial intelligence. So we've got a master's program in artificial intelligence, and we've got a master's program in data science. So in those, what you'll be studying is going from the kind of fundamentals. So it's starting with the kind of classical model, well, the models that today are considered to be classical, but is still incredibly relevant. So models like KNN, so K nearest neighbor, and decision trees. So they are really important to know. So we have an introductory module where we'll cover those. And we'll be taking that through to things like variational modeling, to graph-based modeling, right through to deep learning, convolutional neural networks, and transformers that are important today. And we have optional modules in things like computer vision, natural language processing, generative AI. So I think there is more information on our websites about those modules. And we've got, especially in the past couple of years, we've really been redeveloping our facilities. So we've got some state-of-the-art facilities in terms of model development, but also in terms of data visualization. So one thing we developed in the past couple of years is a data immersion suite. So this really allows for kind of immersive study in terms of data science. I can't remember how many screens we have, but we have a huge number of screens going all around the room. that allow for kind of efficient data visualization. So it's really interesting to work in there. And we've recently revamped our labs as well. So we have these really fantastic lab spaces that are all GPU enabled, so that you can actually do model training and development in those labs, which is kind of unusual. And we have one of the biggest facilities for this in the UK. In terms of master's degrees, you've generally, broadly speaking, got two choices if you're interested in doing a master's degree. You can either do an MRes, which is a master's by research, which basically means that you come up with a project with a supervisor and you spend a year focusing on that project. The alternative to that, the one that is a lot more common, is called a taught master's degree. So the idea is that you take some modules and you do also a research project, but it's maybe a slightly shorter research project. Okay. So the kind of difference between them is really in terms of what you want to do later. So if you are really research focused and you want to do a PhD, then you can take either, of course, but an MRes might be more interesting for you. If you're interested in getting into some kind of employment in artificial intelligence with a company, then probably the taught master's degree is going to be more interesting for you. Okay? So if you do want to know more about the MRes, I put my email address at the start of the presentation. So you're very welcome to send me an email to ask me more about that. But in terms of the taught master's degree, so we've got two, so they're quite similar. So we've got data science and artificial intelligence. So they're both really focused on skills and employability. In both of them, we have a 14-week project, which is generally, I think, considered to be one of the most important aspects of this. So the difference between them is that in data science, you've got kind of more of a focus on data analysis and statistics, whereas in artificial intelligence, you've got more of a focus on kind of applied mathematics and computer science. So your focus is going to be more on machine learning and generative AI in artificial intelligence, whereas you'll be looking at statistical learning in data science. So really the question of which one you choose depends on, which area you'd lean into. But there are some shared modules between the programs, you know. So the placement is something that is generally considered really important. So you'll have in the first term, you'll have some modules, and then over the summer, you'll have a research placement. So you'll have a supervisor in the university still who will support you, and then you will work actually within a company. And we've got a huge range of companies that you can work with. So we've got the Bank of England, we've got AstraZeneca, which is a very important company in Cambridge. If anyone likes nice cars, we work with Bentley as well. And the really nice thing about that I find is that a lot of my students who work with these companies get to know the company. So the companies sometimes treat this like a kind of 14-week interview with somebody, and a surprising number of them actually end up working for the companies afterwards. Not all of them, of course. Some of them go on to different companies like Samsung and Delta, Amazon, PricewaterhouseCoopers. So we also have quite a lot of scholarships available. I'm not an expert in the scholarships, to be honest. But we have a lot more. There's people at the university that you can contact. If you're interested in more information, you can contact me and I can put you in touch with the relevant people. But we have tuition fee waivers for the LU Global Scholarship and the FST Dean's Award. In a nutshell, it means that you can apply for up to a £10,000 discount, which I think, especially these days, I've paid for a master's degree myself and they're very expensive. So having the scholarships available is a really great thing, I think. Okay, so thanks for listening. So I hope that was useful. I hope it was interesting. I think the core message from this, I think, really is that AI is something that it's reached the point that it is infiltrating our daily lives, and it is here to stay. And it's not just going to stay; it's going to develop, and it's going to get bigger and bigger and bigger. And what scares me in the future is that people are going to be working with it who don't understand it, who are going to be working off a feeling, or they're going to be listening to hype and buzzwords. And what we really need, and this is really critical now, is people who actually have an underlying fundamental understanding of artificial intelligence. And that's why I really do think that taking postgraduate study, whether it's an MSc, an MRes, a PhD, at Lancaster or somewhere else in artificial intelligence is so important these days. Okay, so thank you very much for listening. And I think we have maybe 10 minutes or so for some questions.
Yes,
if I'm right.
definitely. Thank you so much, Dr. Williams, for the
Thank you.
insightful session. So I request everyone to put down your questions in the chat, in the QA box. So you have 5 minutes to just put down your questions. Yeah, so Dr. Williams, we have one more questions from one of the attendee. What is the eligibility criteria for admission?
Good question, good question, good question. So it depends partly on your background. I think I did sort of skip over it. Sorry about that. So our entry requirements for data science and AI, they're similar but slightly different. So ultimately, if you have a background in computer science or mathematics, any kind of quantitative subject, then your minimum requirement is a 2-2. If you don't necessarily have a quantitative background, but you have a 2-1 in another subject, then you're eligible for the data science program. And for artificial intelligence, what we're trying to do is make that one a little broader so that a kind of quantitative background, it is really, really important, in fact, to learn quantitative skills and to learn mathematics of AI, and they are absolutely fundamental and included in the program. But we're trying to take it from a point of view where people don't necessarily have a background in mathematics, and we teach that mathematics within the program. Okay, so the entrance requirements for your MSc in AI are a 2-2 in any discipline. So it used to be historically that any master's program would require a 2-1, but there's been a kind of national shift towards 2-2.
Okay. Another question from one of the attendee. What are the essential AI tools we need for mechanical and aerospace area?
Okay, interesting. Um, so what are the essential tools you need for aerospace? It really depends on what kind of in how the aerospace is a very big area. Um, in terms of data science, it really depends on which particular area you're working in aerospace. So you're talking more partly about working with more general data in terms of aerospace engineering. So the focus would be more on statistical based approaches. But if you can send a follow-up question, what exactly area of aerospace do you mean? Because
Okay.
it's a very broad
Uh,
question to answer that one.
so request to elaborate a question more so that
Please.
so next question, how we use cybersecurity is AI can replace the cybersecurity expert in future or not? If yes, then how it can?
Sorry, was that can AI replace the cybersecurity expert?
Yeah, could I repeat the question once again?
Yes, please. I think we've got a bit of lag in the
Yeah, sure.
connection.
No problem. Yeah. How we can use this in cybersecurity is AI can replace the cybersecurity expert in future or not? If yes, then how it can?
Okay, so now, I mean, so cybersecurity is itself is another area that's quite broad. So in terms of AI replacing cybersecurity experts, my feeling is no, it's not going to replace cybersecurity experts. What it's going to do is change the role of a cybersecurity expert. One of the more challenging things that we have, especially in the area of cybersecurity, is that AI is actually enabling, especially in advances in quantum AI, are actually enabling cyber attacks, a lot more sophisticated cyber attacks. So what AI is going to do is, in fact, just change the role. and what a cybersecurity expert would need to focus on. So would it replace certain jobs? I suspect yes, because there are certain jobs that that can be reasonably automated even now. Um, there's still in cyber, there's still going to be the element of the customer service role. So it doesn't make sense, of course, that AI will just replace the entire job itself. Even if AI can do the technical job, cyber is not a purely technical area. But I think the critical point in cyber is that our focus is in fact on AI making cyber attacks more difficult to detect, more complex to tackle. So it's actually going the other way around. So I think that the kind of advancements we've got in AI is going to make cyber experts even more essential to have in the future. And it's just going to change what you need to know as cyber. And that's why all of these kind of new courses and modules and things like that in secure AI, in AI for cyber are emerging because that's a really important area. And we have a couple of experts in the department who focus on secure AI. We have an undergraduate module, in fact, running right now on secure AI.
Yeah, thank you. Another question would be where there'll be an opportunity to work with professor on any project or work as a research student while doing MSc.
Yes. So there's two ways that you can do that, in fact. So actually what quite a lot of we have some very, very keen undergraduate and postgraduate students who want to work on some kind of current research project. So quite often we get emails from students or they speak to us after lectures and they ask if there's any kind of research project they can get involved in. And it's really great to see that enthusiasm. So we can always arrange for something like that. So you can do it as a kind of side project alongside your study, or for the 14-week project that you will have in the second over the summer, sorry, you have a choice of working. Well, you can work with a company, which is what most people do. Um, and when you're working with the company, you're also working with um, the professor. So you're sort of you're working on a project and you're trying to satisfy what the company wants you to do, and you're satisfying what the professor wants you to do. Um, and the focus of that is usually the company provides the problem, and the company provides the problem, so the student studies the problem with the company, and then the student with the professor develop the solution to that. Another ever so slightly different way that you can kind of work on that is that you don't necessarily have to work with a company. So you can actually work on a project which is a purely research-based project with a professor, and you can do, just with the professor for the whole time.
Okay,
So
thank
yeah,
you.
there's quite a lot of opportunity there.
Yeah. What would be a better way for using AI sustainably? Should we limit it to certain department of people or create a system that requires less environmental resources or totally flip and use other resources?
Wow, that's a good question. That's a very good question. It's interesting actually. I mean, this is so the question of sustainable AI is one that has arisen. I mean, it's not arisen recently. It's just being more studied recently. And there's the question initially and predominantly of what actually is the problem? What is causing that problem? I always envisaged that the problem was that with AI being more popular, there's far more people who are actually studying AI and kind of developing AI models, right? So, for example, with CVPR, which is kind of our main conference, we've gone from having maybe a few thousand people, a few hundred or a few thousand people attending that conference and submitting work to that conference a few years ago to, I think last year we had 30,000 people, which is huge. So this is so it's a really big area, and I always thought that okay, the sustainability problems is with people training models, and really overtraining models, which we kind of have to do for conferences. You have to do so much experimentation. But in fact, according to the current sustainability the area, the knowledge within the area, the problem is in fact with the deployment of artificial intelligence, which is really interesting. I did not know that until very recently. So apparently the problem is with actually the deployment of these models and the fact that, well, many people are running ChatGPT commands every day. So that's where the issue is. And there's no simple answer to that question. So there's the question of building kind of foundation models or consolidated models. There's the question of building smaller models. Um, I don't believe that I have believed in the past that AI should kind of be restricted to only people who are actually working kind of genuinely in AI development, who are really working towards the advancement of AI rather than doing kind of simple application projects. I'm not sure I believe that that's necessarily true, especially these days, because you need to develop it. So I think ultimately there's not a simple answer to that question. Um, but there needs to be work kind of on all sides and building efficient models and I think there needs to be a question of constraining and regulating the release of AI models. And I think that as well will contribute towards sustainability.
Okay. Next question. What all skills are required? Sorry, just a minute. Yeah. What all skills are required to become data scientist?
Okay. Honestly, at this level, so at master's level, um, you're transitioning in a way from sort of almost generalized study that we do at undergraduate degree. I mean, undergraduate degree is not generalized study of hyper focusing on one particular topic. But you're starting now to specialize on a master's degree. And honestly, I have said many times when I look at my master's students and my PhD students, the traits that I value the most are interest and hard work. And those are the two key things that you need. They really are. So you have to be interested in it. You have to have some motivation for doing it. It's not the kind of subject that you just kind of study just on the side, and then you just take some revision the night before the exam and hopefully pass. It's something that you really have to be interested in. You have to work harder. In terms of the kind of knowledge that you need really for data science, um, you need you need an understanding of mathematics, of statistics for sure, but you don't necessarily need it right now. So I worry that a lot of people are kind of put off learning about artificial intelligence once they realize just how mathematics dependent it is. Um, and the reality is that they should be aware of this, of course, but they shouldn't be put off, I think, because all of this kind of statistics, this kind of mathematics can be learned. It just takes time. Um, so really, I think the skills in order to, by the end of the master's degree, you need to be able to, for sure, code in Python, and or coding in R. Those are relatively straightforward skills, to be honest, that you will pick up. If you don't have them already, you will pick them up during the master's degree. It's just going to make your life easier if you've got them already. You need to be able to develop an understanding of mathematics. So the kind of things that you'll certainly want to know by the end of the program are things like derivatives, integration, properties of integration. Convolution is a really important concept. So one of the tricks that I sort of tell my undergrads to do if they're kind of they've started my module and they're not really it wasn't quite what they expected, is I try to get in a lecture on convolution early on or integration early on so that they can sort of see what's going on there and they can decide if they like it or not. Because really, if they don't like it, then it's maybe not the subject for them. So I mean, if so, that is if for anybody who's not necessarily got what might be considered the perfect background or the kind of traditional background, it's worth just looking into some of the concepts and seeing if it's something that you'd want to learn during the master's degree.
Yeah, so the last question for today, for mechanical engineering students, does AI play any important role in their career? And if yes, how do the student develop their skills in AI if they are from biomaths background?
Okay, interesting, interesting, interesting. So I would say that the two topics are very closely related. Because in both cases you need a fundamental understanding of mathematics, of mathematical modeling and of statistics. But I think your question is, how is AI possibly going to change that in the future? So the way that I can see AI being involved in the future is more of a supporting methodology to help you out. It's one of these kind of careers that I don't think AI is going to replace entirely. So in terms of what do you need to know in order to utilize this methodology, certainly as a mechanical engineer, I think anybody would expect, if you're using kind of AI, that you would have some kind of underlying understanding of the methodology that you're using. And certainly if you're building something, I mean, suppose you're building something like a bridge, then you need to have an understanding of the tools that you're using and how they're going to fare with what you're designing. So in terms of what you would necessarily need to know in relation to AI, I think you'd need to understand how these tools are developed and what they mean. So studying things like computer vision and natural language processing is going to be really relevant, and it's going to be something that's very accessible to a mechanical engineer.
Thank you. So I request all attendees to reach out to your consultant, your counselors for any further questions. So thank you so much once again, Dr. Williams, to join us today for such an insightful session. And I request all the attendees to receive, they can receive their certificates online on their registered email ID. Thank you so much, everyone, for joining in.